Alright, here's another gas law type problem. We've got a gas at 28 degrees Celsius, has a volume of 65 liters and a pressure of 1135 torr. Calculate the final temperature of the gas when the volume is 50 liters and the pressure is 1465 torr. So let's figure out what this problem's given us and what we need to solve this problem. So the first thing we encounter is a temperature, 28 degrees Celsius. It has a volume of 65.0 liters and a pressure of 1135 torr. And we were looking for our final temperature. So this is a before and after problem, right? So that means we've got P1s and T1s and P2s and T2s. So we're looking for the final temperature when the volume is 50 milliliters, or 50 liters, sorry. And the pressure is 1465 torr. So our P2 is 1465 torr. So now we go shopping for a formula. I think on our formula sheet we've got a formula that includes n's, but in here we don't mention anything about numbers of moles. So we're just going to assume that the number of moles are going to be constant, and we'll use the combined gas law formula. P1 V1 over T1 is equal to P2 V2 over T2. So now we're looking for T2. We got it down here in the numerator. The denominator. Anytime I'm looking for a variable that's in a denominator, it just makes life a lot simpler if I just cross multiply it and get rid of the fractions altogether. So if I cross multiply this, I end up with P1 V1 T2 is equal to P2 V2 T1, right? So we've got just cross multiply that. Now I'm looking for T2, so I got to undo the what's being done to T2. I can't write and talk at the same time. Thought I could. So we're just going to divide P1, divide each side by P1 V1, and they're going to cancel over here. So I'm just going to rewrite that equation down here. T1 T2 is equal to P2 V2 T1 over P1 V1. And we're ready to plug some numbers in here. First, let's take a look. Do we need to do any conversions? Okay, I got torr and torr, so that's good. I got liters and liters. I've got Celsius, but we know we can't do Celsius. We've got to have this in Kelvin. So we're going to add 273 to it. So that's going to give us 301 Kelvin as our T1. So we're ready to plug our numbers in here. We've got 1465 torr times my V2, which is 50.0 liters, times my T1, which was 301 Kelvin. And then we're going to divide this all by my P1, which was 1135 torr, and 1465 torr. That looks like a decimal point. I'm going to get rid of that. There we go. So now I'm ready to plug this in my calculator, find out what T2 is equal to. So I'm going to take 1465 times 50 times 301. And I'm going to take that answer, I'm going to divide it by 1135. I'm going to hit enter. And I'm going to divide that by 14. Yeah, let's take a look. I put 1465 in here twice. That's a goof. Right? I put my P2 in instead of my V1. Sorry about that. My V1 was 65.0 liters. I knew something looked screwy there. So what I didn't do beforehand was make sure my units canceled. That's why I made a mistake here. So let's plug these numbers again. 1465 times 50 times 301 divided by 1135, and then divide that answer by 65. And if I do that, my T2 gives us 299 Kelvin. Really 298.8580, whatever. So I'll round it up to 299 Kelvin. Let's see if we can make sense of this answer here. We've got our volume decreased a little bit. So that means it usually corresponds to a decrease in temperature. And my pressure increased. So that usually corresponds to an increase in temperature. So they're kind of duking it out there. So they kind of are going to somewhat cancel those effects. So that should give me a temperature that's close to what my original temperature was. So this is an answer that makes sense. So this is using our combined gas law.